Hi students, good morning everyone. This is Ram Sarup, a maths faculty. I welcome you all to Turito live classes. So children, today I am going to discuss about the class 10, the first chapter, that is a real number. So let us start children our class. Children, in this class today we are going to learn about first introduction of real numbers. Next one, division algorithm and a equivalent division lemma. After that, some problems related to what? To finding the HCF by using the what? Equivalent division algorithm. So children, these are the things we are going to learn in this class. Clear children? So shall we start the class? Right. Children, what is a real number? So how we can define the real number? Any idea children? So what is a real number? So what numbers we can call them into real numbers? Any idea? Okay. So before going to learn this real number, so do we need to have the knowledge of anything children? Tell me. So what knowledge we should have first? So we should know about what we should know about, tell me children? We should know about a natural number and we should know about whole numbers and integers and rational numbers and irrational numbers. Children, once you know about these all types of numbers, then only you can understand what is a real number, isn't it? So first let us know what is a natural number, like whole number and integers and rational number and irrational number. So let us have the knowledge of this type of numbers, then we can discuss what is a real number. Clear children? Yes. Now children, can you tell me what is a natural number? How we can define the natural number? Anything? Anyone, please tell me. Children, already you learned this natural number somewhere in a 6th class. I guess maybe 6th class or somewhere 7th class. So I guess it is only 6th class children. So you have to say what is a natural number. Okay. Children, natural numbers are what? These are the counting numbers. When I ask you to count something, so what you do generally? You start from 1, isn't it? You start from 1, then go 2, then 3, then 4 and 5 and so on, isn't it? So these numbers we can call into what we call children, these numbers? We call them into what? A natural numbers. So generally natural numbers are what? Start 1 to infinite. Like starting from 1, then 2, 3 and so on infinity. Okay. So these numbers we can call a natural numbers. Children, let us have the definition of natural number. The natural numbers are what? A part of the what? A number system. Okay. And start from what children? 1 to infinite. Start from what? Number 1 to and infinity. Children, here infinity means what children? Countless. There is no ending. So that is called what? Infinity here. See children, otherwise we can say the counting numbers also called what? Natural numbers. Counting number like start from 1, 2, 3, 4 and so on infinity. So these numbers we can call them into what? A natural number. Clear children? Yes. Now my question is, how we are going to represent a natural number? Do we have any letter to represent the natural number first of all? Tell me children, do we have any natural number symbol? Yes, we have the symbol. Children, natural numbers are represented by English capital letter is what? Capital N. Here N nothing but what? Natural number. Okay. See, the natural numbers are represented by what? The English capital letter is what? A capital N. So we can use the English capital letter is what? Capital N to represent the what? A set of natural numbers. Okay. Okay. Next one. Children, can you tell me what is the smallest natural number? Yes, tell me. Yes, the smallest natural number is what children? It is 1. Because the starting number is 1 only. The starting number is 1 means can't we say that the smallest natural number is 1? Yes. The smallest number is what? 1 is the smallest natural number. Okay. Then my question is, can you tell me children what is the greatest natural number? Tell me. So how we can define the greatest natural number? Children, remember the greatest natural number is we cannot define. Because these numbers are what? Uncountable. When the numbers are uncountable, so how can you say the last number? Is it possible to decide what is the last number? No, it is not possible. So in that case, what we can say? The greatest natural number is not defined. Okay? So we can say the greatest natural number is what, children? It is not defined. Clear, children? The greatest natural number is what? Not defined. So children, it is about the natural number. Clear, everyone? Okay. Then next type of number is what? A whole number. So what is the whole number? Any idea? So how we can define the whole number and how we represent the whole numbers? And what is the smallest number and what is the greatest whole number? Anything. Okay, simple, children. Children, whole numbers are what? These numbers are start from 0. When the number is start from 0, we can call them into what? A whole number. Like these numbers start from 0 to and so on infinitely. Like 0, 1, 2, 3, 4, 5 and so on infinity. That means starting number we can say it is 0. Again same thing, we cannot say what is the last number. The ending number is what? It is impossible to say. Isn't it? So we can say these numbers are start from 0, 1, 2, 3, so on and infinity. So set of these numbers we can call what, children? A whole number. Right? Now my question is how we are going to represent this whole number again? So what way we can represent? Natural number means we are using the letter is capital N. So what about the whole numbers? So do we have any letter, special letter for represent the whole numbers? Yes, children, we have the letter. So we can go, the English capital letter is capital W. We can use the what? The letter capital W to represent the what? The set of the whole numbers. See. The whole numbers are represented by what? The English capital letter is what, children? The capital W. Okay. So we can write W is equal to what? 0, 1, 2, 3 and so on infinity. So these are the what, children? The set of whole numbers. Okay. So W is nothing but set of the whole numbers. These are start from 0, 1, 2, 3 and so on infinity. Clear, children? Now my question is, what is the smallest whole number? Tell me, children. By looking at the set of the whole numbers, you can say easy answer. Tell me. Yes, it is 0. Because see, the number is what? Starting from 0. The number is starting from 0 means we can say it is a what? A smallest whole number. Yes. Therefore, what I can say, children? The smallest whole number is a 0. Okay. Now, what is the greatest whole number? Can you define me, children? What is the greatest whole number? So, what would be the greatest whole number in the set of the whole number list? Is it 6 or 7? No, children. The greatest whole number also, it is not possible to define because these numbers are what? Uncountable. When the numbers are uncountable, we cannot define what is the greatest number and we do not know where the numbers are going to be end. So, in that case, we cannot define the greatest whole number. Clear, children? Okay. Children, my question is, can I say all the natural numbers are whole numbers? Tell me. Can I say all natural are whole numbers? Tell me, children. Can I say all the natural numbers are whole numbers? Is it possible to say? Yes, children, we can say. We can say all the natural numbers are, we can say whole numbers. Because all the list of the natural numbers are what? Present in the list of the whole numbers also. So we can say all the natural numbers are whole numbers. So that is possible. Now, can we say all the whole numbers are natural number? Tell me, say. Can we say this all the whole numbers are natural number? Is it possible to say? Think once. Can we say or can't we say? Because we cannot say. Because of 0. The 0 is what? Present in the only whole number list. It is not in the present in what? The list of natural number. So, it is not possible. We can say only all the natural numbers are whole numbers, but we cannot say all the whole numbers are natural number because of the 0. Am I clear, children, everyone, this point? Yes, very good. Then children, after the whole numbers, what is the next type of the numbers? Tell me. Integers. So can you tell me, children, what is the integer? How we can define the integer? Again, same thing. So what is the symbol for representing the integers? And what is the smallest integer? And what is the greatest integers? Again, same we will going to discuss in this list also, like integer list. Please tell me, children, what is the integer? How we can define integer? Anything. So very simple, children. Integer is nothing but what? The collection. Children, what is the meaning of collection? The collection of positive and negative. The collection of positive and negative. So this complete collection, we can say what? The set of integers. Okay. So what is the meaning of positive number, children? First, let us have the definition. The collection of a negative numbers. First point is what? The collection of negative numbers and the collection of a positive numbers. We have negative and we have the positive along with one more number. So what is the one more number, children? That is 0. That complete collection, we can say what, children? Integers. You have the list of the what? A negative integers. You have the list of the positive integers, and along with one more number, that is 0. So this complete group or this complete collection, we can say what, children? Integers. Okay. So that is a what? A definition of integer. And children, how we can? Okay, fine. Positive integers means what, children? How we can define the positive integers? See, I am writing some numbers here. Just identify which are the positive integers. 1, 2, 3, 4, 5, 6, and so on. So I can say these are all numbers are what? A positive numbers. Okay. So how we can define the positive numbers means the numbers are what? Greater than 0. Okay. The numbers are what, children? The greater than 0. So those numbers we can call a positive integers. Okay. Next, negative. Okay, you can take the examples also. See, 1, 2, 3, and so on infinity. You can take all the set of the positive numbers, like all it has positive symbol. And my question, what is a negative integer, children? So how we can define the negative integer? Again, same thing. The numbers which are what? Less than 0. Like you can take -4, you can take -3, and -2, -1. You can take something -55. You can take something -100. You can take something -500, -300. So these are all numbers we can say what, children? The list of negative integers. Positive symbol means, or positive numbers mean the numbers which are greater than 0, and the negative integers means what, children? The numbers less than 0. So I can say these all numbers are what? A less than 0, and these numbers we can call them into negative integers. Clear, children, this point? Yeah. Next one. See, you can take the example something -1, -2, -3, and so on. Okay. These are the example for what? A negative integer. Next, children, 0. Fine, we know like positive integers and we know negative integers. And what about the 0, children? So can we say 0 is a negative integer or positive integer? Children, 0 is the what? Neither positive. It is what? It is neither positive and neither negative. 0 we cannot say positive number, and 0 we cannot say negative number. Okay. So 0 does not have any symbol. It's a not plus number. It is not a negative number. But generally we take 0 as considering as a positive number. Okay. But practically, like otherwise, as per the definition, 0 is not a positive or not negative. Fine. But how we are going to represent the again same integers? So which symbol we use, children, to represent the what? The set of the integers. So which symbol we use? Children, we use the two symbols, like two letters. One is Z or one more is I. You can use the letter is capital Z or you can use the letter as capital I, any one, children. So generally we go for what? Only capital Z. Okay, we can use capital I or we can use capital Z. Children, remember, suppose I am writing Z plus. So whenever I am writing, children, Z plus means, so what you have to understand? So it is set of only a positive numbers. So to represent the positive numbers, I am writing as Z plus form. So Z something plus. If I am writing something Z minus, so what you have to understand, children? Z minus means I am writing only set of negative integers. So this is what? A negative integers. So that is what, children? Negative integers Z plus and Z minus. Clear, children, everyone? Or any doubts regarding this? And one more thing point I wanted to share with children. The smallest integer also what? Not defined. The smallest integer and the greatest integer. So these two are what? Not defined. The smallest integer also not defined and the greatest integer also not defined. Okay, remember this point also. So take it as something, it is a note point. And children, we can write Z is equal to what? So it is a what? A list of all the integers. So we have the positive integers and we have the negative integers and along with 0. So this complete set, we can say what, children? Integers. Clear? Fine. Next, children, what is the rational number? So how we can define the rational number? In what way? So this is also one type of the number, children. So we have to learn this also, very, very important. So what is the rational number? How we can define the rational number? Children, remember, rational. Rational means actually it is a ratio. Okay. So rational means it's something ratio. Then what is the meaning of ratio again? Ratio means what, children? Something upon something. That is called a ratio form, isn't it? So what is this something and what is this something? Generally, this something we can say a numerator and this something we can say denominator. Okay. So generally the rational number can be what? Something? A ratio form, like numerator and denominator form, isn't it? So what is the actual definition? The rational number? The rational number nothing but if a number can you write in the form of P by Q. If you can write the number, otherwise if you represent any number in the form of P by Q, such numbers are called what? Irrational numbers. Okay. But do we have condition for selecting the P and Q? Or you can take any value. So what is the criteria for selection the P and Q, children? Any conditions do we have for selecting the P and Q? Yes, we have. P, children, always integer. And when Q also always integer. So both are integer only. You can take P also integer and you can take Q also integer. But the thing is what, children? This Q cannot be 0. This Q is what? It is not equal to 0. Why? Because if I take Q equal to 0, I'll get what? Undefined form, isn't it? So because of that reason, what we are taking? We are taking both are integers, that's fine. But the thing is what? Denominator should not be equal to 0. Clear, children, this point? Once have the definition, children. These numbers are what, children? In the form of P by Q. I told you already. Okay. And where P and Q both are what, children? Both are integers. And one more condition, Q is not equal to 0. Then those numbers we can call rational number. Okay. You can take one example, children. See, it is called a rational number, P by Q form. P is any integer, Q also any integer, but Q should be what? A non-zero integer. Okay. So that condition you have to remember. Next one. Types of example. Okay, we'll see some examples of rational number. Can I say it is a rational number, children? Yes, it is a rational number. Like it is in the form of P by Q. And what about this, children? Minus 3 upon 4. Can I say it is a rational number? Yes, this is also a rational number. See, we have the numerator and we have the denominator. And denominator is what here? Non-zero integer. And what about this 0.3? Yes, this 0.3 I can write as 3 upon 10. So 3 upon 10 means it has a numerator and it has a denominator. And minus 0.7. Can I say this also rational number? Yes, minus 0.7 also we can write as minus 7 by 10. Okay. Next to these numbers. So these type of all the decimal number, children. This actually what? A non-terminating and repeating decimal expansion. Non-terminating repeating decimal expansions also what? Examples of a rational number. Okay. Those numbers we can write in the form of P by Q. Next one. Types of rational numbers. Like what are the best example you can say generally? We can say all the integers we can say rational numbers. Next one. Fractional numbers, which have the numerator and denominator integers. So these also we can say examples of what? Rational numbers only. Next one, terminating decimal examples. Like 0.35, it is a termination decimal. This also terminating decimal. This also terminating decimal. So these all terminating decimals also we can say example for what? A rational numbers. Next one, I told you already. A non-terminating repeating decimal expansion. I'll give an example. You can take 0.6666 and so on. Children, this number I can say a non-terminating repeating decimal expansion. So this number we can write as what, children? 0.6 bar, and this number we can write in the form of P by Q. So such type of examples also we can say rational numbers. Okay, so I'm sure you have clear, children, everything about this rational number definition and along with the example. Okay, and children, how we can represent the rational numbers? So rational numbers are represented by English capital letter. It is capital Q. Generally Q nothing but here quotient. So how you will get the quotient? When you are dividing the two numbers. So that is the way here Q is a rational number. See, children, any doubts regarding this examples and definition? No. Fine. Now, children, irrational number. Rational, irrational. Can you think, children, can I say both are quite opposite words? Rational means what? P by Q form. Irrational means not in the P by Q form. Okay. So rational means P by Q. Irrational means not in the P by Q form. If you are not able to write in the a number in the P by Q form, so such type of numbers we can say irrational numbers, isn't it? Just have the definition, children. Irrational numbers are what? Same again, real numbers, but these numbers can't be represented as simple fraction. Here simple fraction means what? P by Q form. See here. If we cannot represent in the form of P by Q, see. If we cannot represent in the form of P by Q, such such numbers we can say irrational numbers. You can take example root 2. It is not possible to write in the P by Q form. Root 3, not possible. You can take pi value. Pi also best example for irrational. Okay. You can take example, children. Pi I can take as a what? Irrational number. Okay. And you can take generally, children, remember this, pi is not equal to 22 by 7. You might be thinking pi is what? 22 by 7. So 22 by 7 is what? Something P by Q form. So we can say pi is what? A rational number. Isn't it, children? No. Pi is what? Irrational number, but we are taking the close value as 22 by 7 for our calculation purpose. It is not exactly 22 by 7. It is very close to value. Okay. So pi also we can say irrational number. And you can say all the sets. I remember, children, I told you already. 22 by 7 is a what? It is a rational number, but it is not equal to pi again. Pi is different, 22 by 7 is different. Next one, children, Euler number. So this number also I can say irrational number. You can, children, you can take some other number like root 3, root 7 and something 6.3, 4, 5, 6, something 8, 3, 2 and so on. Like non-terminating and non-repeating decimal expansions also we can take the examples of what? Irrational number. Okay. And children, how we can represent the irrational numbers? So irrational numbers are represented by what? Q bar. Q nothing but rational, Q bar nothing but irrational. So remember, here Q, this is rational, Q bar, This is irrational. That's it, children. Very simple. Q is a rational, Q bar is irrational. Clear, children, regarding this irrational number? Okay. Now, children, real number. So, what is a real number? Real number is nothing but it is a combination, otherwise collection of what? Rational and irrational. So, this complete collection we can say real number, children. Okay? You can say rational number is a what? Real number. You can say irrational number, even though we can say real number. Okay? So, what I can say, children, every number is a real number only. So, what is our definition? Real numbers can be defined as is a union. Union means what here? It's together here. Together of, what is the number? Rational number and irrational number. Like Q plus Q bar is equal to what? We can say R. Here R nothing but a real number. So generally real numbers are what? Represented as the English capital letter is what? Capital R. Here R is a what, children? Real number. It is a what? A combination. Otherwise you can take collection of a rational number and irrational number. So together if you put one place, so that is called what, children? A real number. Okay? Next. And children, remember this. We can say all the natural numbers and decimals, fractions, and all these numbers we can say comes under what? A real number only. I told you just now. Every number you can say real number, children. Okay? So that is a definition of a real number. And see, rational numbers, I can say real number. Integers, I can say real number. Whole numbers, I can say real number. And natural number, I can say again real number. Next one is what? Irrational number. So this also what? I can say real number only. So this set completely, I can say real number. Okay. Now children, look at here chart, real number. It is the what? Rational and irrational. So children, irrational means we don't have again classification, but rational number we have classification. So we can say non-integer rational number, again integer rational number. So integer means again something a negative and positive. Again means positive means here we can take something a whole number. And whole numbers means what, children? It is a zero and natural number. So this is a complete chart of what? A real number. Just have the look of this, children. Chart is a very simple. So by looking at the chart also you can understand easily, you can remember it. Clear? Fine. Next, children, a division algorithm. So what is a division algorithm? Tell me, children. How we can teach division algorithm? Any idea? What is a division algorithm? Okay. Children, listen here. I take the two numbers. One number is 14, another number is 3. So what I wanted to do is, this 14 I wanted to express as multiples of something 3. Okay. So how I am writing this 14? This 14 is equal to, I am writing 3 into 4. So 3 4 is how much? 12. So what is the leftover number? 2. So this formation, we can say division algorithm. Like 14 is equal to, we can write as 3 into 4, that is 3 4 is 12, and 12 plus 2 is equal to what? 14. So it is called what? A division algorithm. Okay. Generally, children, here 14 is called what? A dividend. And this 3 is called what? A divisor. And this 4 is called what? Quotient. And this 2 is called what? A remainder. Okay. So this complete set or this complete formation, we can say division algorithm. Clear, children? Now let us see the one definition of division algorithm. A division algorithm says that when a number A, I am dividing with what? Some other number is B. If you are dividing the number A, dividing with what? Some other number is something B. If the quotient is Q and the remainder is R. So how we are going to represent, children? We can write as A is equal to BQ plus R. Okay, here A is the what? A dividend, and B is equal to what? A divisor, and Q is the quotient, and R is the what? A remainder. So this is a remainder. And children, remember here R is what? Always greater than or equal to 0 and less than divisor. So that is a what? A division algorithm. Clear children? Any doubt regarding this division algorithm? So very simple. A is equal to, I am writing BQ plus R. Here A is a dividend and B is a divisor and Q is a quotient and R is a remainder. And what is the boundary for R? Like limit? Remainder is what? Always greater than or equal to 0 but less than divisor. That is a what? 0 is greater than or equal to, sorry, R is what? Greater than or equal to 0 and less than B. Clear children this condition? Any doubts? So this is actually we can call a division algorithm. Okay, fine. Now children, we have an example here. Let us do a small example children, so you will be understand better. Children, I want to divide this 117 divided by 4. So how we are writing? 117 and this is 4. Children, you can take this number is A and you can take this number is B. Okay. And remember children, here A is what? Always greater than B. Then only we can write as A is equal to some multiples of B and some number, isn't it? Now, how we can write? 117 is equal to, tell me children, 14 how many times? So 14, tell me, 6 times or 7 times? 14 6 are? Tell me children, 84. 14 7 are 98. So 14 8 are? What is the 14 8 children? It is 112. So we can take 14 8 is 112. So 117 it is 112. So 117 minus 112, what is the value? 5. So we can write the remainder as 5. See, this I am writing as what? By using division algorithm. So this is what? A value, and this is what? A B value, and this is a quotient, and this is a remainder. Children, remainder can be 0 also. It's not compulsory, always it has some number. It can be 0, but it always less than what? A divisor. Okay, so that condition you have to remember. Now let us see another example children. If a number is what? Divided by 73 and gives a what? 34 as a quotient and 23 as a remainder, then find the number. So what is it children? If a number is divided by 73, so I am taking the number is what? A. I don't know the number. Dividing with what children? 73. Can I say B is equal to 73 here? I have told you already. B is a what? A divisor. Next, quotient is 23. So Q is equal to how much? 23. Remainder is equal to what? Sorry, quotient is what? 34, not 23. Okay. So quotient is what? A 34 and remainder is equal to what children? It is 23. So what is that number? Very simple. Apply the division algorithm. So A is equal to BQ plus R. So B value how much children? It is 73. And quotient is equal to what? A 34. And remainder is equal to how much? 23. So children, multiply 73 and 34. So this is 73 and 34. 12, 29. So this is 2, this is 8, 3 and 2. This is 2, 3, 8, 2. Check it children, 4 3 12, carry 1. 4 7 are 28, 29. 3 3 are 9 and 3 7 are 21. Sorry, this is 4. Okay. So this is 2, this is 18, carry 1, this is 4 and this is 2. So 2482. Plus, what is the remainder children? 23. So add this 2482, remainder is equal to 23. So 2 plus 3, this is 5 and this is 0 and this is carry 1, 5 and 5. So the total answer is equal to how much? 2505. Clear children? So very simple children, so you can apply easily here division algorithm. Okay, fine. Next to equal division algorithm, or we can say equal division lemma. It's same like division algorithm only children. It's a very simple again. If I take A is a one number, I am taking B is a one number. You think that A is what? Greater than B. Then how we can write children? By using the equal division algorithm. Same again. A is equal to, we can write as BQ plus R, and R is what? Greater than or equal to 0 and less than B. So this is Euclid division algorithm. So by using this Euclid division algorithm, we can find the HCF of numbers. Okay. So here A is some number and B is actually we can take A is what? A dividend, and B is what? A divisor, and Q is a quotient, and R is what? A remainder. Okay. So children, look at the one's definition. So Euclid division lemma, we can say children lemma, otherwise we can say division algorithm. Both are same only. Okay. So don't get confused. Lemma means something. Okay. Both are same only. We can say lemma or algorithm. Okay. So what it states children? Given two positive integers, children remember this algorithm we can apply only a positive integers. Negative integers we cannot apply this lemma. Okay. Only positive integers A and B. So number A and B. So how we can write? A is equal to, we can write as BQ plus R, where R is equal to what children? Greater than or equal to 0 and less than B. So children remember this. This is a very important condition. So R is always greater than or equal to 0 and less than B. Okay. And this algorithm, what we do children generally? To find the HCF of numbers. If you have any two numbers or children three numbers, we can use this algorithm to find the HCF. Children, let us see one small example. First of all, tell me how we can find this HCF of two numbers by division algorithm. It's very simple children. First find, okay, we'll do one thing. First you can take A is the one number and B is the one number. If you are writing A is equal to what? Something BQ plus R. First, write A is equal to what? BQ plus R. If you are getting remainder is equal to 0 children. Okay. In case if you are getting remainder is equal to 0, then we can say B is a HCF. Okay. B is a HCF. Suppose if you don't get remainder is equal to 0, you are getting the remainder is what? A non-zero number. Then what we have to do? Very simple. So take the B and take the R. So write down the B is equal to R. So do one thing children, take the B and R. So write down the B is equal to R into C something D children, and C and D some other number. Here D is equal to, you can take as something remainder. If you get the remainder D is equal to 0, then we can say R is a what? HCF. So the same procedure we have to continue till we get the what? A remainder is equal to 0. See here. Okay. So that is the what? Euclid division algorithm. Now children, let us see a small example. By using the division algorithm, find the HCF of 50 and 70. Children, I want to find the HCF of what? A 70 and 50. Children, here A is equal to what? First we will take 70 is what? Greater than 50. So we can take A is equal to 70 and B is equal to 50. So what is the division algorithm children? Euclid division algorithm. We can write as A is equal to BQ plus R, where R is equal to what? Greater than or equal to 0 and less than B. So this is Euclid division algorithm condition. Now here A is equal to what? 70. 70 is equal to, now tell me children, 50 how many times 70 we can take? 51 da 50, 52 is 100, so can't go 2 times, so we can go only 1 time. So 51 is 50. So remainder where they? How much? What is the 50? 70 minus 50. Yes, it is 20. Children, this can I say 20 is the remainder? Yes. Can I say it is equal to 0 children? No, it is not equal to 0. If it is not equal to 0 means what I told you children? we have to take that 50 and we have to take that 20 as a combination. So what I am writing, 50 is equal to, I am writing as 20 into, so 20 how many times children? 20 ones are 20, 22s are 40, 23s are 60. We can go for only 22 times. If 22s is 40, so 50 minus 40, what is the value? 10. So write down the remainder is 10. Children, you write down again, remainder is what here? Not equal to 0. Isn't it? The remainder not equal to 0 means we can still continue the same procedure. Okay. Now what I am taking? I am taking 20 and 10. So 20 is equal to what I am writing, children? 10 into 2 plus 0 is the remainder. So here what I can say, children? Remainder r is equal to 0 here. So remainder r is equal to 0 mean here where we got, children, 0 at divisor 10, isn't it? So we can say HCF is 10. Okay, so this is a procedure for finding the HCF of any two numbers by applying what? Equaloid division algorithm. See children, any doubts regarding this sum? First take the two numbers and apply the equaloid division algorithm, and then what we have to do, children? Just check it. If the remainder is equal to 0, then stop it there only. If the remainder is not equal to 0, then take the divisor and take the what? Remainder. As a one combination, again apply the same equaloid division algorithm. So you continue just till this process where, children, up to you get the remainder value is equal to 0. Okay. So this procedure we can say what? Equaloid division algorithm. See children, any doubts regarding this procedure? It's a very, very simple, children. You can easily understand, and one or two questions if you do the practice well. Okay. Okay, fine children, let us see another example also. Next two. Actually what we have discussed in this class? We have discussed our introduction of real numbers. I told you already. It's a combination of what, children? A rational number and irrational number. Next one, a division algorithm, like basic division algorithm, I told you clearly. And next one is what? Equaloid division lemma. That is what? A is equal to what? BQ plus R, where R is what? Greater than or equal to 0 and less than B. So that is equaloid division lemma. And next one, some related question. Related question means what? Finding the HCF. So by using the what? A division lemma algorithm, by finding the HCF. Okay. So this is actually summary of this class, children. I hope you understand this all the points and there will not be any doubts, children, I guess. So first thing is real numbers, we know definition, we got everything, and division algorithm also very simple, and equaloid division lemma. Children, these both are same only, but thing is what? This equaloid division lemma we used to find the HCF of the numbers. Okay children, fine. Children, let us discuss some question again related to same equaloid division algorithm. Children, look at the first question. Use the equaloid division algorithm, find the HCF of what? 135 and 225. Children, here the given numbers is what? 135 and 225. So I can say 225 is greater than what? 135, isn't it? So when the number is greater than means we can take this number is A. You can take A is what? A 225, and you can take B is equal to what? A 135. That's the first condition. And what is the equaloid division algorithm condition, children? A is equal to BQ plus R. Here R is equal to what? Tell me, what is the condition for R? I told you, R is what? Greater than or equal to 0 and less than B. So it is a condition for what? Remainder. So remainder is what? Always greater than or equal to 0 and less than B. Now children, apply here. A is equal to 225 is equal to B. B nothing but what, children? Here divisor. What is the value? 135 into. Now children, 135. How many times we can take? Is it one time or two time? Tell me children. We can take only one time. So we can take one time. Then 135 and this 225. 225 minus 135. What is the value? Just do the subtraction. 225 and 135. So this is 0. 12 minus 3. What is the value? It is 9. So we can write as remainder is 90. Then children, take the combination of 135 and 90. So 135 I can write as, now tell me children, 90 how many times? We can go only one time, children. Then what is the remainder? 45 is the remainder. Because 91 is the 90. So 135 minus 90 is 45. Now take these two as one combination. So 90 I am writing as 45 into 2. Then remainder is equal to what? 0. Children, remember here remainder is not equal to 0. Here also remainder is not equal to 0. But here I got the remainder equal to 0. Therefore, I can say what is the HCF, children? 45 is the HCF. See, children, any doubts regarding this question? Question is very simple. They have given the two numbers, it's a 135 and 225. Then we need to find the what HCF of the both the numbers by using the equivalent division algorithm. So this is a solution, children. So how, any doubts, children, regarding this class? Any like topics, real number, equivalent division algorithm and division algorithm and related questions? It's a very simple, children. You try to practice more, so you'll be getting like all doubts will be clarified easily. Okay, thank you, children. Thank you so much for your valuable time.